All right, so here we have the first question. I'll scroll down to the first part. It reads determine the SI base units of K. The first step is to rearrange K and then insert the base units of all the quantities given in the question, given in this equation. Force is kgms minus 2. Radius of the sphere r is meters, not millimeters. And the speed is meter per second. These are the SI base units. Now you can clearly see meters cancelled out by one of the meters. So what are you left with? Kg. 1 meter from downstairs would be m minus 1. Then s minus 2 plus 1, because minus 1 from downstairs would be plus 1. So you'll be left with this thing. Let's move on to the next part. Use the value of upthrust acting on the sphere to calculate the density of the liquid. So upthrust equals to rho density of liquid times g times v stand for the volume of the object. Now the value of upthrust must be given in the question. 4.8 into 10 to the power minus 4. The density of the liquid we don't know. 9.81. Now the volume of the object. What kind of object do we have? We have a sphere. The radius of the sphere is 2.1 millimeters. We can find the volume from there. So 4 over 3 pi r cube. Radius is 2.1 millimeters, or in meters would be 0.0021 and cube of it. Okay, so you need to write it down all together in calculator. Press the fraction button. 4.8 into 10 to the power minus 4. This 3 would be multiplied on the other side. Everything else with rho would be divided on the other side. So open up the calculator, write down this expression as it is. And then let me know what do we get. The answer in 2SF, I think the answer that you get on the calculator is 1260650 something. In 2SF, we can round it off to 10 raised to the power 3. Now that looks a very dramatic answer. 1261. Yeah, that's more like it. 1261. So you should write on the calculator as it is. Make sure you're writing in fraction. 1261 into SF, I can write it as 1300. What do we call that? 1300 kg m minus 3. That's the density. And then on the diagram, we need to represent by the arrows, and we need to show the direction of weight, upthrust, and the drag force. So vertically downwards from the center of the object would be weight, upthrust would be vertically upward, and the drag force would also be upward because the motion is downward. So drag force they have represented by the symbol FV, viscous drag. F sub V represents viscous drag. Let's move on to the next one. Determine the magnitude of the terminal velocity of the sphere. So the formula that was given for the viscous drag was KRV. We can easily find the value of V from here. V would be KR. Now what is the viscous drag? How much force is that? We don't know. but we can write the expression of these three forces since it is moving with constant velocity. So the sum of downward forces should equal to the sum of upward forces. These two forces were upward, upthrust and drag force. I need to find the drag force, so that equals to weight minus upthrust. So weight was how much? 7.2 into 10 to the power minus 4. Upthrust is 4.8 into 10 to the power minus 4. 7.2 into 10 to the power minus 4 minus 4.8 into 10 to the power minus 4. So the force that we get is 2.4. I'm going to insert the value of force over here now. This value would be 2.4 into 10 to the power minus 4 as it is, divided by K. The value of K in SI base units is 17. So I'll write 17 here. And the radius of the sphere was 0.0021. And if you hit it on the calculator in 2SF, you'll be getting 6.7 into 10 to the power minus 3. So I did write the answer in 2SF, but if you want to write in 3SF, that's also fine. So let's move on to the next question. Question number 2 looks like from the topic of projectile motion. Show that the time taken for the arrow to reach the target is 1.08. We're not provided with the velocity in x direction and in y direction. So first, let me draw the components of the velocity. So let's say this is the velocity, and one of the component is along x-axis, which would be 65 times cos of the given angle, 4.3, and the vertical component would be 65 times sine 4.3. Why do I draw the components? Because I know in the question of projectile motion, one way or the other, you have to use the components. Now let us find these two values quickly. 65 times 4.3, so we don't have to use the angle, we'll use these values. So if anyone can give me these two values, velocity in x and velocity in y. Okay, so y is 4.87. So this one would be used as 4.87. This is the initial velocity in y along y-axis, or the initial vertical velocity, and the other one is 64.81. This is the initial horizontal component of the velocity. We need to find the time taken to reach the target is 1.08. Primarily, we should go with the horizontal motion. For horizontal motion, we have a single equation: speed equals to displacement over time, or velocity equals to displacement over time. Then time equals to displacement over velocity. What is the horizontal displacement? 70.0. What is the time? Sorry, what is the horizontal speed or the velocity? Well, it is over here 64.81. If you solve it on the calculator, you'll be getting 1.08 seconds. Then calculate the height of the center of the target above the ground. So center of the target is someplace over here. We need to find the height of it above the ground. So if we know, if somehow we can find this distance, this vertical displacement, this one, Then we can subtract that one from the total of 1.66, and then we can find the height from the ground. This one we can find afterwards. But first we need to find this value. So this is the height, the displacement that would be covered by the projectile along y-axis. So let me write down the equation, which is compatible in this case, s equals to ut plus 1 over 2 at square. Displacement is to be found out. We represent it by x. Your choice if you want to write s as it is. U represents the initial velocity, and this equation is now being applied for y-axis. Keep it in your mind. It's now being applied for y-axis. And matter of fact, the equations of motion are used for y-axis because it's a vertical component which has the acceleration. So the initial was 4.87 and time is 1.08 plus 1 over 2 as it is. Acceleration we always use with the negative sign for the sign convention, minus 9.81 times 1.08 and square of it. So find me the value of this one quickly. Yeah, I think for this one it should be, we have some place over here, minus 0.46. You can confirm if we get this one, minus 0.46 meters. Now what do we mean by the negative sign? You see, this is the advantage of the sign convention. According to the sign convention, if your displacement is negative, it means you're landing below the reference or below the initial reference. So you're someplace over here. Okay, you're below the reference. So this is what we mean by the negative sign. So how much is that? 0.46. So the value of x, the negative simply means it is below the reference. But what is the value? 0.46. I need to find this one. So I can subtract these to 1.66 minus 0.46. So how much is that? If we subtract these two, we get 1.2 meters. By considering the energy changes state and explain how the final kinetic energy of the arrow as it hits the target compares with the initial kinetic energy. Okay, a numerical calculation is not required. You see, as it hits the center of the target, its gravitational potential energy decreases. So what happens to that decrease in gravitational potential energy? It decreases, and then since one form of energy is being decreased, it is being converted into kinetic energy. So GPE decreases, and if we compare with the kinetic energy, so that decrease in gravitational potential energy must correspond to increase in kinetic energy. And you can write this in description. State what is meant by the center of gravity. The point where entire weight appears to be acting. I've seen many students, they won't write this thing. The point where entire weight appears to act or is taken to act or is considered to be acting. So I'll skip this one for a while. And then we have this one. we need to find the vertical component of the force exerted on the wire by the beam. Okay, so we have this force over here, which is kind of tilted. So I'm going to draw the components of this force. It will then be easy for us. So these are the two components. And this one would be 45 sine this angle, and this one would be 45 cos of the given angle. Okay, so calculate the vertical component of tension 45 times sine 37. It would be 27 into SF, would be 27. By taking the moments about A, calculate the weight of the block. So weight of the block needs to be found out. So we need the vertical forces, for which we have the perpendicular distance from the pivot. This force won't be used because it passes through the pivot. So the perpendicular distance from the pivot would be 0. Let me label the forces clockwise, anti-clockwise. If this is a pivot, then this one would be clockwise, this one would be clockwise, and only one of them would be anti-clockwise. Now let us write the expression. And then I can copy paste the expression. So anti-clockwise is, how much was it? 27. So this value is basically 27. 27 times, what is the perpendicular distance from the pivot? 0.56 equals, what is the first clockwise? 23. What about the perpendicular distance of that one? It's a uniform beam and the length of the beam is 0.96. So it should be exactly in the middle. So 0.48 plus the moment produced by the other force, which is a weight W, times, what about the perpendicular distance of that force from the pivot? It would be 0.56 plus 0.20. So it should be 0.76. Then what you do on the calculator all at once, W equals to, so W equals to 27 times 0.56 minus 23 times 0.48 divided by 0.76. Do it on the calculator all at once. And you will be getting 5.4 as the weight into SF. Calculate the horizontal component of this force. Okay, so how much was that? 45 times cos 37. Should be 36. The block is now placed closer to the point D on the beam. State whether this change will increase, decrease, or have no effect on the tension in the wire. Okay, so if you place the block closer, let's say the block is now placed over here. So if you place the block closer to the point D, this would decrease the clockwise moment, and hence the anti-clockwise moment should also be decreased. So the tension in the wire would be reduced. So you don't need to state and explain. You simply need to state. So even if you write it decreases, the tension in the wire decreases, that would also be acceptable. Okay, then we have the next one. The stress in the wire is initially this one, and now they have a wire with different radius, and you need to find the new stress. So stress equals to force over the area. Stress equals to force over area is pi r square for the circular cross section area. Now you need to compare the two stresses. So you can write this expression as, and you say this thing is given over here. The tension in the wire remains unchanged. So the force remains same. The force remains same. All right, force remains same. So this is for the first wire. All of it is for the first wire, and for the second wire you'll have the same expression, but with just with different subscripts. Anything which is same for both of them can be removed. Now since force is same, so I can compare these two equations. So sigma, which means stress, pi r, this thing equals to the second stress, sorry, the second force. Anything which is common would be eliminated. So sigma 1 times r1 square equals to sigma 2 times r2 square. So sigma 1 as it is, 5.3 into 10 to the power 7. This is the first stress. The radius was r square. The first radius we assume r square as it is. The new stress needs to be found out times, what is the new radius? The new radius is 3 times greater. So 3r square of it. So 5.3 into 10 to the power 7 times r square equals to sigma 2 times 9 r square. R square cancelled out, and sigma 2, the new stress equals to 5.3 into 10 to the power 7 divided by 9. If you hit it on the calculator, you'll be getting 5.9 into 10 to the power 6 into SF. What you get is 5.8888 into 10 to the power 6 into SF can be written as 5.9 into 10 to the power 6. Now, what is the alternate method by which you can solve this question? First of all, the thing is, the situation is that you provided with a certain value of stress against a certain radius, and then afterwards they change the radius, and now you need to find the new strength. New stress. So you need to find the relation between two quantities, stress and the radius. What is the relation between these two? Stress equals to force over area. And for the circular wire with the circular cross section, the area would be pi r square. Then, since force and pi is constant, so the relation between the remaining quantities is pretty simple. Stress is inversely proportional to the square of the radius. Okay, this is what we know now. Stress inversely proportional to the square of the radius. How do we know that? Mathematically. Now what you can do is you can use the process of ratio method. So you can write stress here and you can write radius here. Afterwards, what is the initial stress? 5.7 5.3 into 10 raised power 7. What is the initial radius? First of all, the thing is, you don't have the relation between stress and the radius, rather you have the relation between stress and the square of the radius. The most important thing, the relation that we have mathematically is not between stress and radius, it is always between stress and square of radius mathematically. So what is the initial radius? We don't know, so I'm going to call it 1. So I'll write square of 1 here. Now what is the new stress? I mean, we don't know, that is part of the question, so I'll write x here. But what is the new radius? 3 times than the original. So if the original is 1, now the new one has to be 3. But here we write the square of the radius because the expression is between stress and square of radius. Afterwards, let me ask you something. Shall we cross multiply or shall we multiply in the line? And what is the criteria? Anyone who can answer. This is a basic question of mathematics. Now, in order to find the value of x, shall we cross multiply or shall we multiply in the line? Anyone who can answer this question? And what is the criteria? Cross. Okay, cross. Let me tell you one thing. You cross multiply only if the two quantities are directly proportional. In the line, yes. In this case, we multiply in the line because these two quantities are not directly proportional, as we can see through the expression that these two quantities are inversely proportional. So whenever two quantities are inversely proportional, you never multiply in the cross, you multiply in the line. So 5.3 into 10 raised power 7 times 1 equals to x times square of 3. Square of 3 is 9 into x. Now what is x? 5.3 into 10 raised power 7 times 1 doesn't make any difference, divided by 9. And what do you get then? Whether you like it or not, you'll be getting exactly the same answer, which is 5.9 into 10 raised power 6 Pascal. Uh, Now in this one, if I take a look at the question, you're not provided with the velocities. Generally, in these kind of situation, you're provided with the velocities. So this is the initial momentum. This is the initial momentum of y. This is a momentum after collision of x, and this is a momentum after collision of y. So what is the expression for law of conservation of momentum? Anyway, we'll come to that one afterwards, because first we need to find the mass of the block x. The kinetic energy is given. The kinetic energy of x is 0.30 joules, and the momentum of x is also given as 0.37. Now what is the relation? I mean, you should memorize this formula. P square over 2m. Kinetic energy equals to square of momentum divided by 2m. The derivation is also included in the syllabus. I'm not going to derive it right now. You want to see the derivation, you can check it out in the workbook of momentum. It is from the expression of kinetic energy, and then instead of mv you write momentum, and for the other v you write it as momentum over mass. So this is 0.37 sorry, let me insert the values now. Kinetic energy is 0.30, momentum is 0.37 square divided by 2 times m as it is. So m equals to 0.37 square divided by 2 times 0.30. So if you solve for the value of mass in 2SF, you'll be getting 0.23. Calculate the magnitude of the momentum of block Y after the collision. So easiest one, momentum after collision equals to momentum before collision. So momentum, the total momentum before equals to the total momentum after. So what is the total momentum before? 0.37 plus the negative of 0.65. Because the sign convention of momentum is important, the left side would be negative and the right side would be positive. This is what the convention is. Equals momentum after collision, which equals to the momentum of x plus the momentum of y. So what we have is momentum of x would once again be with the negative sign because it is still to the left side, plus the momentum of y after the collision. We don't know. I'm going to write x, but what I know is it should be with the negative sign because it is to the left side, and according to my convention should be with the negative sign. So if you solve for the value of x, you'll be getting minus 0.15. But since in this one they have asked for the magnitude only, so I can write it as 0.15. Then the block X exerts an average force of 7.7 Newton on the block Y during the collision. Calculate the time that block are in contact with each other. So one block exert a force of 7.7 on Y. Y also exerts the same force on X. So force equals to average force equals to rate of change of momentum. We can solve it with respect to the object X, and we can also solve it with respect to the object Y. So it's totally your choice. I'm going to solve it with respect to the object X. So the force exerted by the block X equals to the rate of change of momentum of X divided by time. So delta T thereby equals to rate of change of momentum of X divided by force exerted by X. Now what is the change of momentum of X? So that would be initial momentum of X is this one, final momentum of X is this one. What is the change in momentum? So change in momentum would be final minus initial. Final momentum minus initial momentum. So what is final? 0.13 with the negative sign. Keep take a notice of the sign convention. For momentum, sign convention is really important. So this is final momentum of X minus, what is the initial? 0.37. So what is the change in momentum of X? Minus 0.50. So minus 0.50 divided by what is the average force? 7.7. Now whatever your answer is, you can get rid of the negative sign afterwards, because for the time we need only the positive values, and the negative sign in the change of momentum is only giving you the direction of change in momentum. So the direction of change in momentum is to the left side. So delta T is 0.065 into SF. Question number 5. So here we have question number 5. A beaker in the air contains the liquid. Okay, I mean, I'll scroll down to the main part. In the first one, you need to show pressure equals to rho gh. So what we know is pressure equals to force over area, and then force equals to the weight of the object. Then W equals to mg over A. Then pressure equals to mass times G. Area can be written as, you see, volume equals to area into the length, which in this case is the depth. So volume equals to area into depth, thereby area equals to volume over depth. So volume over depth. Now you know how to deal with fraction over fraction. So M, instead of mass, I'll write density into volume. Instead of mass, I've written density into volume, and then divided by volume, and this H would be shifted upstairs. And you know this one. Now fraction over fraction, it goes to the numerator. What do we have then? Volume, sorry, I missed this one, G here. Yeah, volume cancelled out by volume, and you're left with rho G H. So probably the easiest 3 marks in the entire paper. Suggest why why this equation does not give the total pressure. For total pressure, we have to compensate the pressure for the pressure of liquid plus the atmospheric pressure. So what you say in description, you can say because we have to take account of atmospheric pressure also. So that's why this formula does not give you the total pressure. Now we have the next one. And this is also a question many of the students were struggling with this one. There are 2 tricky things in this one. One of them is that this is a graph for the total pressure. This is not the graph for the pressure of the liquid only. How do we know? Because even at when the depth is 0, even at the surface of the liquid, you still have a specific pressure. How much is that? That pressure is 9.60, and many of the students forget to add the exponent, into 10 raised power 4 Pascal. So this is the atmospheric pressure basically. So this is the container, it contains the liquid. At the depth 0 means you're at the surface. So the total pressure that you have at the surface would simply be the atmospheric pressure. So the atmospheric pressure is this one. We need to find the density of the liquid. Now let us use the expression. Total pressure equals to atmospheric pressure plus the pressure of the liquid, which means rho g h. So rho, the density, needs to be found out. Now what is the total pressure? You can take any point. I'll take the last one. This is the easiest one. 9.66 into 10 raised power 4 is the total pressure. What was the atmospheric pressure? 9.60 into 10 raised power 4. So basically the point where the depth is 0 gives you the value of the atmospheric pressure. Okay, what do we have afterwards? Yes, plus rho as it is because we need to find the value of the density. G is 9.81. And what is the height or depth of the liquid at that point, the one that we have chosen? 8 centimeters. So I need to get rid of centimeters. 0.08. So basically 8 divided by 100. You hit it on the calculator, you find the density, and the answer that you'll be getting is, I'll just copy paste the answer now. You can try for yourself if you get a different answer. So in 2SF, 770. So in the marking scheme, 760 is also acceptable. So anything between 760 and 770 is acceptable. Okay, let's move on to the next one. The diagram looks scary, but the question is not. Let me be very honest. The question for 2 marks. You need to find the new tension in the wire. What is the tension in the wire right now? The tension in the wire is 0.53. So the situation is, let me tell you the situation first. So this is a situation. Initially, the object was here on the surface of the liquid, and there was tension. You could measure the value of the tension, which would simply be the weight of the object. But then the situation is, you lower this thing inside the container, you dip it in the water, you dip it in the liquid, and now the new value of tension is to be found out. The first question is that you should realize that this value of tension should be smaller because an upward push is being provided by the upthrust. So this would also experience the upthrust force. And if we are able to find the upthrust, we will simply subtract that upthrust from the original tension, which equals to the weight of the object, the previous one. So let us find the upthrust first. So upthrust equals to rho density of liquid times g times volume of the object. What is the density of the liquid? We calculated previously, 770 times 9.81 times the volume, which is not given directly, but you can use the information, the length and the cross section area. If you multiply these two, you get the volume. 3.7 into 10 to the power minus 4 times length is 4 into 10 to the power minus 2. So the upthrust that you get by this process is 0.11. Or let me just find it out myself. 770 times 9.81 times 3.7 times 4 times 10 raised power collectively would be minus 6. Yeah, 0.111. So I'll write it as 0.11. So this is the upward push that would be provided by the liquid to the object, to the cylinder. Now, what would be the new tension? So, the new tension would be the previous one. Okay, this is the previous one minus the upthrust, minus the upthrust 0.11. So the tension in this case would be smaller because a vertical push, a vertical force, an upward push is provided by the liquid that we know by the name upthrust. So you subtract these two and you'll be getting 0.42 Newton. I'll simply read the main things here. First, the train approaches towards the observer, and then the train passes the observer at t equals to t1 from time t equals to 0 until it is well past the observer at t equals to t2. Okay, so initially it approaches the observer and then it goes away from the observer. When the train approaches the observer, the frequency would be, the observed frequency would be more than the source frequency. It would be constant and more than, you don't need to write this one, this is just for the reference, and the observed frequency is more than the source frequency when the train was approaching. And when the train moves away from the observer, I should write this one, away from the graph. You never know. The students might be thinking this is a part of the answer. So the frequency has to be constant, and when the train is approaching, the observed frequency has to be greater than source. What do we call this effect? The name of this effect is the Doppler's effect. Now, after t1 till t2, the train now goes away from the observer, so the observed frequency would be less than the source frequency. That's why we draw a horizontal line at the bottom, and these two should be pretty much at the same distance. Okay, just pretty much. There should not be a dramatic difference, like the first one is slightly above and then the second one is way too much away from Fs. No, should be pretty much at the same distance. Okay, let's move on to the next one, the power of the incident wave. Okay, so the intensity is given and the radius is given. The formula of the intensity is intensity equals to power over area. Power equals to intensity times area. Area of cross section intensity is 4.7 into 10 to the power minus 3. Area of cross section would be pi r square. The radius is 2.8 centimeters, so it is 0.028 meters. Alright, so this is what we have. Simply write this thing as it is on the calculator and you'll be getting 1.15 something. So in 2SF we can write it as 1.2 into 10 raised power minus 5 with the unit watts. I don't know why this one is 3 marks. Probably due to the conversion and to use the formula of area indirectly. Yeah, from the formula you have the division of marks is C1 for this, C1 for 1 mark for the formula of intensity, and 1 mark for the formula of area, pi times r square. So if you do these two steps, you get 2 marks. Okay, state what is meant by Kirchhoff's first law. You can write in description, sum of currents entering and the sum of currents exiting a junction or a point are equal. So sum of the currents entering a junction is equal to the sum of currents exiting the junction or leaving the junction. Now this is the next question that we have. RT equals to R1 plus R2. That needs to be shown. These are the easiest 2 marks that you can have from the electricity. So this is a series circuit. The derivation of this expression starts with V total voltage equals to V1 plus V2. Then you say V equals to IR. Hence, this expression can be written as IT RT equals to I1 R1 plus I2 R2. Then you say, all of a sudden, you realize this thing that the current is same in the series circuit. So if the current is same in the series circuit, you don't even need to write the subscript. You can simply represent it by I. You don't need to write the subscript. What do you do afterwards? You can take I common from the right side. And to be honest, I've seen every kind of derivation of this expression in the papers. Soon as you start believing you have now seen the worst one, there comes the other one, challenging the worst one. Okay, then we have the part C. Okay, let me keep check on the. Sir, are we sketching the graph for observed frequency or for source frequency? We were sketching the graph for the observed frequency. For the frequency, actually for the frequency. The if we were sketching the graph for the source frequency, the graph is already there. The source frequency never changes. Whether the object is moving towards you, whether it's moving away from you, whether the object is stationary, accelerating, whatever, the source frequency never changes. It is kind of the actual frequency. Calculate the internal resistance R of the cell. Okay, just in case, can I find the current in the circuit? So current in the circuit would be the voltage across these two divided by the resistance of these two. So what is the voltage across these two? Well, the voltage across these two resistors is equal to the terminal voltage, which is 1.35. The terminal potential difference of the cell is 1.35. The actual EMF was 1.5. Some of the voltage is dropped over here, and the leftover voltage is 1.35, and the leftover voltage would be there across both of them collectively, 1.35. So current equals to voltage divided by the total resistance of these two, which I assume is 25. 10 plus 15, 25. So what is the current in the circuit? 1.35 divided by 25. 0.054. So just in case the current is 0.054 amperes, which I am convinced we'll have to find for the internal resistance. Now there are multiple ways for the formula of internal resistance, or simply in order to calculate the internal resistance, you need the voltage across the internal resistance divided by the current flowing through the internal resistance. And matter of fact, I should not even use the subscript for the current because current is same in the series circuit. Now what is the voltage across the internal resistance? Let's see. It should be very easy. So EMF of the battery is 1.5 volts. Across the terminal, we are getting only 1.35 volts. So what about the leftover? What about the remaining voltage? That voltage is dissipated across the internal resistance. So how many volts do we have over here across this one? 0.15 volts. So 0.15 divided by, what was the current? The current is same in the series circuit, 0.054. Divided by answer, I'm getting 2.7 bar. So 2.777, which into SF would be 2.8. Okay, let me check the chat box also. Okay, no message so far. So let's move on to the next one. Okay, now I can see they have added another resistor R3 in parallel with the first two. State the effect. State and explain the effect, if any, on the change of this change on the current in the cell. If you add a resistor in parallel, the total resistance decreases, hence the current in the circuit would increase. Write this one in description, you'll be getting 2 marks. So what do we say? Adding a resistor in parallel, the total resistance of the circuit decreases, hence the total current in the circuit increases. What happens to terminal potential of the cell? Okay, so formula of terminal potential is this one. So as the current increases, as the current is increased because of the resistor in parallel, so a larger value would be subtracted, or more voltage would be dropped across the internal resistor, hence the value of V would be less. So more potential difference across the internal resistor, hence potential difference of the cell, or the terminal potential difference, will be decreased. So I mean, for electricity, here we have nuclei of the isotope copper each have 29 proton, and okay, and they emit beta negative. They emit beta negative particle. All right, fair enough. State the nuclei notation in the form of XZA for this nucleus of copper. Copper, 29 protons, and how many? What is your atomic mass? 29 plus 37. 66. That's it. This is a graph whenever you have whenever we have the beta decay. So this is a graph of the kinetic energy. It was there in the notes also, that the beta decay, the beta particles, they do not have discrete values of energy, rather they have the continuous range of the energies. Why is that? Because there must be an extra particle, there must be another particle which would be possessing the remaining energy, and that particle is known as neutrino. But if you have beta negative, then it is known as antineutrino. So how do we answer this one? Energy of the overall decay is constant. The energy during the decay is constant, but the energy of beta particles, this one, beta, you can say negative, as shown in figure 7.1. Energy of these particles is, or is in a range of values another particle, which they'll ask you the name for this in the next part. Another particle must possess the remaining energy. And what is the name of this particle? I told you guys, whenever you have the beta negative decay, that particle which is released alongside is antineutrino. Okay, then we have the copper isotope. It decays into zinc, and the decay is beta negative, so we need to write the equation. So these are the easiest 3 marks that you can have. Copper 2966, as mentioned above. It decays into zinc. We don't know the values, the atomic number and the atomic mass, so we'll wait for a while. And this is the beta negative decay. For beta negative, what do we have? -1 here, 0 at the top. Alongside the beta negative, what do we have? Alongside beta negative, we always have the antineutrino. Now we can find these two values, the atomic number. So we have 29 on the left side. On the right side, the total should also be 29. So if we have 30 here, only then we can have 29 on both sides. Now on the left side at the top, the atomic mass is 66. On the right side, we have 0. So it would be 66 here, only if we have 66 for zinc. Now the rule is the sum of these should be equal to the sum of these. And this value over here should be equal to the sum of these.